Here we go. Luckily, these first few are easy. It says determine if the ordered pair is a solution to the system. Okay, just plug it in. This is X, this is Y. Make sure it works for both. So we're going to plug in -3 for the X and 5 for the Y in both equations. -3 for the X and 5 for the Y. Okay, let's see what we get. -6 plus 30 equals 24. Yeah, that sounds about right. Boom. -3 plus 25 equals 3? Don't think so. Okay. So we're going to say not a solution. It has to work for both. You can't just work for one. Visually, what that looks like is, okay, -3, 5. One of the lines does go through it. One of the lines doesn't, right? And the solution is supposed to be where the two lines cross. So this guy is not a solution because he's not where the two lines cross. All right. Let's try it again. 0 for the X, 1/2 for the Y. Zero for the X, 1/2 for the Y. All right, these guys are goners. Half of 10 is 5. That works. Half of -6 is -3. That works. So it is a solution. Hey, both go through 0.5. Whatever this line is and whatever that line is, they both go through it. It's a solution. All right. Now let's talk about the cases we can have. The cases we can have are the following. So only 3 things that can happen here. Either the lines cross and we get one solution. Where the lines touch is the solution. Okay. But we could get no solution, you guys. So what do you think that would look like? If I told you, hey, where they cross is the solution, so I've got no solution, well, what do the lines look like?
Maybe almost parallel or something like that.
Something exactly like that. Yeah. There you go. That's how we're going to get no solution, is from some parallel lines. And finally, we have one more case of infinitely many solutions. So where they touch is a solution. So apparently these things touch infinitely many times. So imagine a line on top of another line. So where they touch is, infinitely many points here, right? Okay. You don't want to say all reals. I always get students who are like all reals, and I see why they would say that, but it's not all reals. That's not a solution. That's not a solution. That's not a solution, right? So you can't say everybody, but you can say there's a lot of them. Okay, so just watch your language on that. You want to put infinitely many down. Okay. Now, when we have other names for these, you guys, so I'll just tell you them now. If you get a solution, it is consistent. So we got an answer here, and we got a lot of answers here, right? If you don't get a solution, it's called inconsistent. Okay, inconsistent. Also, we have another word, dependent. When a line is on top of another line like this, that is our only dependent case. You can tell one line totally depends on the other line, right? These other two would be independent cases. The lines aren't right on top of each other, so these are considered independent. So if you get a solution, it's consistent. If you don't get a solution, it's inconsistent. If the lines are right on top of each other, then they kind of depend on each other. The other two are independent. Okay. So we're going to solve systems of equations. So you're going to start to see more than one equation. You might have 2, you might have 3, As you get into linear algebra, which we have here, you could have, you know, tons of equations. The most we'll do in this class is 3. Okay. So how we solve them, there's really 2 different ways that we usually do it. One is the substitution method, which we'll do here, and one is the elimination method. So for the substitution method, you look at your 2 equations and you go, okay, I want to isolate one of the variables, and you kind of pick who would be easiest. For me, I'm looking at this guy right here going, he looks the easiest to isolate. Okay, so that's what we're going to do. So isolate y in the bottom equation. That seems the easiest. All right, so let's go ahead and take the bottom equation and we'll isolate y. So we could really quickly isolate y if we just move them over to the other side and then move the 26 over. Do a little switcheroo here. So 5x plus 26 equals positive y. There, we isolated the y. That was easy. All right, now what you're going to do for step 2 is you are going to plug that into the other equation. Make sure you do the other, okay? Don't plug it back into the same one. All right, so we're going to take that and we're going to take our other equation, which is this guy. And instead of writing y, well, we now know that y is 5x plus 26. So we're going to put it in his place. So we basically wrote this guy out, but we didn't write y. We just put 5x plus 26 in there. All right, so here we go. 2x plus 15x plus 78 equals 10. We'll add these 2 together. Minus the 78. And divide by 17. Now don't stop here. I always have a lot of students, because I don't get multiple choice for this test, that just box that and go on. We're supposed to find the point where these 2 lines cross, right? So far, we've only found the x value of the point. We need to get the y value, right? So plug that into step 1. Okay. So in other words, put it right here. Okay. All right. So we got the y equals 5 times x plus 26. It looks like y equals 6. So now you have an ordered pair. If we go type these in to GeoGebra, we got negative 4, 6 as the answer, right? And let me go ahead and type those 2 lines. They should cross at that point. Let's see if they do. Hey, there you go. They crossed at A. So that means we did a good job, you guys. Let me get a little picture just to remind us that we're looking for where these lines cross. Oh no. Let's try that again. Now, they might ask you questions like, what kind of lines are they? So let's go ahead and use those new words we learned. Like, is this consistent or inconsistent? Is it dependent or independent? All right. Let's see how
It's
much
dependent, correct?
Yeah, independent, good, because those lines aren't one line right on top of the other, so it's independent. What do we think as far as consistent or inconsistent? Yeah, so consistent because we got a solution. Okay, so it's consistent since we got a solution, and it's independent because it's not one line right on top of the other. Okay. All right. I think they ask you like drop-down menus on Connect where it's like consistent, inconsistent, dependent, independent. Yeah. Okay, cool. Now this is the same exact problem, but they just want us to use the other method. So the other method in some books is called the elimination method, which I kind of like better. Or it just tells you exactly what you're trying to do. You're trying to eliminate somebody. Okay, some teachers say the stack and destroy method, whatever. In your book, it's called the addition method. So in the addition method, what you want to do is you want to be able to add downward and make something cancel, right? So like if I had like negative 3x plus 5y equals 10 and 3x plus 4y equals 8, for example. If I add downward, these cancel, and then I just have y's left. So I can solve it. So that's the goal, is to make one of the variables go away. So that we only have one variable left, solvable, okay? So what we're gonna do is we're gonna get rid of the y's since they seem the easiest to eliminate, okay? Get rid of y's seem easiest to eliminate. Let me elaborate on that, okay? If I were gonna get rid of the x's, which I could do, it's like no biggie, we can do that. But what I would have to do is I would have to multiply this one by 5s to make a 10 there. And then I'd have to multiply by a -2 to make a -10. So I had to multiply both equations if I want to get rid of the x's. Now they'll cancel, so it worked, okay? But what I mean by it's easiest to get rid of the y's is that I don't have to multiply both equations. If I want to get rid of the y's, if this top one's a 3y, well then just multiply this guy by a 3, because what that will do is that'll get us this. 2x plus 3y equals 10. And when I distribute the 3, 15x minus 3y equals -78. And now the y's went away. So it's easier in the aspect that I only had to multiply one equation. Here I had to do the work to both. So that's what I mean by easier, okay? All right, I just want to make sure everybody understood that. Now, let's actually legitimately do it. All right, so we have our two equations. And we decided if we're going to get rid of y's, that I have to turn this into a -3. So this is what will do it. And this looks familiar. You just did this on the last page, huh? Okay, now after you get your x, don't forget to get your y, right? So that looks a little bit differently here. So, oh, that's X. Okay, so you can plug that into either one of the beginning equations. Plug that into either of the original equations. So you just kind of look and go, well, which one do I think seems the easiest? You know, it's the name of the game, man, trying to make your life easy. I'd say probably the bottom one, but it doesn't matter. They both look pretty easy. Actually, maybe the top one, I don't know. They're both so easy, I don't even care. Okay, so let's say we plug it into the bottom one. So we have 5x, but x is -4, minus y equals -26. So we have -20 minus y equals -26. Ooh, I gotta do something really fast. There we go. Okay. Add 20. Divide by -1 to both sides. Or multiply by -1, however you do it, and you got your y. And that's the same point we got on the last problem, so I'm confident that we did it right. Okay. Melanie with the deep questions always. So if you add those together downward, should it always work that answer works for both? I'd have to think on that, Melanie. No one's ever asked me that before. I'd have to think on that. It should definitely work if you plug it into them individually. When you plug it into them together, let's look at a picture, maybe that'll help. So we have that picture already. Adding them together. Now, why does it at that point go through that point again? I don't know if that always works, Melanie. Let me think on that, okay? I mean, it does in this case, but it's always dangerous to say, yeah, that'll always work. You know what I mean? It's like, is there one possible situation where it doesn't? Who knows? So too deep for me in my totally exhausted brain right now. Let me think on that, okay? That was a good one. All right. Okay, so we're gonna have situations where we have decimals, fractions coming up right there, right? We know what to do with those. Right, we've been doing it all class. Just get rid of them, no problem. Okay. So the very first thing that I would do is I would just move the decimals so that I don't have decimals anymore. So let's make this bigger so we can see what's going on. So I can see that I would need to move it once for the very top equation. So moving it once would, you know, turn this guy into a 50. Moving it once would turn this into a 3. And then moving it once would turn this guy into a 14. All right. Okay. Then for the bottom one, once isn't going to cut it. Because if we move it once here, we'll still have a decimal. So it looks like we got to do it twice, you guys. So if I do it twice right here, I'm going to get a 20. If I do it twice right here, I'm going to get a 10. And then a 28. Let me move all that because we're going to need those equations later. But that's what it would look like if you move the decimal twice on that bottom one. And now we're looking at something that's not so hard, okay? All right. All right, it doesn't matter what we get rid of on this one. They're both equally hard. Do you guys want to get rid of the X's or the Y's? The Y's? Okay. All right, so let's go ahead and try to get rid of the Y's. Oops. Sorry. Hi. Sorry, I hope that wasn't super loud. Hi. Okay. All right, so if we're gonna get rid of the y's, you guys, then we'll need to multiply this one by a 10 because that will create 30. And we'd have to multiply this one by a 3 because that'll create negative 30. Remember, if one's positive 30, then the other one has to be negative 30. So here's what we get. Okay. So yeah, that made the y's go away. Boom, those are gone. So if we just add downward, we got 560x equals 4, carry the 1, 12, 13, carry the 1, 234. Oh no, there was no 1 to carry. Sorry guys, super tired, you have no idea. All right, so I don't know why I'm carrying a 1 when I don't need to. All right, so 0, I'm actually like, I have a cold right now, and but I told you guys I was not going to have you watch videos again for the rest of the semester. And so I'm like, okay, I'm doing this. But the downside is because I have a cold, I'm kind of like boring, like and droning on. You guys are like, oh, that's always Mecklenburg, but more so, you know, than usual. All right, let's see what 224 over 560 is. I'm getting like 0.4. But I think some people's calculators gave them out like 2/5. Yeah, something like that. Yeah. Okay. All right. So here's what's customary, not like I care, but if you have a multiple choice, I'll just let you know that because it started as decimals, it's customary to use the decimals. If it starts as fractions, it's customary to use the fractions. So I'm just going to do that so I kind of show you that. All right, so we got 0.4. Do you guys remember what we do with it once we get one of them?
Plug it back in.
Mm-hmm. And you can plug it back in. You could use the beginnings, but you can also use this pink right here because this is the same, it's just with the decimals gone. So I'm going to say I probably would rather plug it into the pink if I got to do it, you know, by hand especially.
I have a question.
Yeah.
So since we moved around decimals in the first place, do we have to move decimals around for the answer? Like
It's a good question.
0.4?
Yeah. So it turns out you don't. Let me see if I can come up with a simple case where we can see that. Let's say that we have something like this, right? 0.5 times, I'm sorry, my pen's totally not working, 5x. Come on, buddy. Equals 1.
Now, you don't have to move the decimal because technically the equations are the same. They're just multiplied.
Yeah, and this little simple ditty might do it, okay? 0.5 times what is 1? Well, we know that a 0.5 plus another 0.5 will add up to 1, right? Okay, so it must be that x equals 2 is the answer. Okay, x equals 2 is the answer to this. Okay, or you could have just divided by 0.5 and put that into your calculator, whatever, but it's 2. Okay, all right. Sorry, my pen's being delayed, bad, and then my computer's delayed. So if I move the decimal once to make this a 5, and I move the decimal once here to make it a 10, you can see that you're still going to get 2 as an answer, okay? Instead of saying, you know, a 0.5 plus a 0.5 makes a 1, you're now saying a 5 plus a 5 makes a 10. So because you move the decimal on both sides, it still is going to get you just regular old 2. You don't have to go and move the decimal back. Did that kind of help you guys?
Yeah, thank you.
Okay, cool. That was a good question. All right. Oh, man. Sorry, everything's glitching. It's one of those days again where my computer's moving in like weird speeds, and then my pen's wrong, going bad. Needs another quadruple A battery. Okay. All right. So I'm thinking let's plug it back into the pink. I'm kind of eyeballing them. I don't know. Do you guys have a preference, top or bottom? Because I don't care. Bottom? All right, let's take this guy back to the bottom then. Okay, I don't want to put an arrow there because people might think you put him in for the Y. We're going to put him right there. All right. So let me use a different color for that. So you've got 20x, but x is really 0.4. Okay, so that is going to be 8 when you multiply 20 times 0.4. So we'll subtract the 8. Okay. So it looks like these guys are supposed to cross at 0.4, comma, -2. Okay, let's see if that's the case. Let's go graph them, see if that's true. Whenever it's decimals, I get kind of like worried where I'm like, did I mess up somewhere? So I'm just so used to whole numbers and stuff. But let's go check it out. All right, so we got 0.4, comma, was it -2? I already forgot. Yeah. Okay. All right, so 0.4, comma, -2. There it is. Now these lines should cross there. So 5x plus 0.3y equals 1.4. 0.2x minus 0.1y equals 0.20. All right, what do you know, you guys? They did cross right there at that point that we drew. How perfect is that? So very cool. Okay. Okay, so they crossed at 0.4, -2. Everything's right, looking good. Now let's go in here and label them again. I don't know why I'm writing stuff. My writing's atrocious. So we're going to label whether or not they're consistent or inconsistent. And then we're going to label whether or not they are dependent or independent. All right. So what do you guys think? Consistent or inconsistent? Consistent, good. And then you even put independent also. Nailed it. Yeah. Very good. Okay. Oops. I don't know why I have the blank slide right there. I'll need to leave that guy out. There we go. Okay. So these don't force your hand. They're just like, go ahead, solve however you want. You know what? I won't usually force your hand most of the time. So, you know, it's your pick. I will tell you, you know, kind of what I use. So in cases where y is already by itself, I use substitution. So like I'd use substitution on this one. I wouldn't on this one. I would on this one. I wouldn't on this one, okay? So if a variable is already isolated, I use substitution.
And you mean basically just plug it in, correct?
Yeah. Yeah. You don't have to work for it when it's already isolated. All right, but it's your call. You know, if you want to use the addition method, what do I care? All right. So yeah, you're right. We can just plug it in. So we're going to take this guy and we're going to plug him in for the y, since that's what y is. The 4's will cancel, so you'll just get a 7. So that's nice right there. And if we divided them both by 11s, then you can see that we have 1/2 for the x. Okay. And we said that in the substitution case, that it's easiest to take that back to the one that's already been isolated. That's the one you always want to take it back to. So we got y equals 5 times 1/2 minus 7/4. All right. So put a 1 underneath, multiply straight across. That's 5/2 we're looking at. And if I want to subtract that, just multiply by 2's here and here so that they have common denominators. 10/4 minus 7/4 is 3/4. So it looks like these lines should cross at 1/2, 3/4. Let's see if we did it correctly. All right. That took too long last time. I'm just going to delete these things. I thought it'd be shorter to refresh the page, but not with my internet. All right, so we had 1/2 and 3/4, right? Okay, there's the point where we're hoping the lines cross. So let's plug in those original equations. Hey, there it is. Looks good. Looks good. All right. Okay, I saw a comment. Open that back up. Yep. Consistent and independent again, huh? Okay. All right. Okay, this is about as gnarly as it gets. You know, I'm not going to give you too much more gnarly than this. So what you want to do is you want to get them into standard form. You know, you want them to look like, this is the goal, like this. Oops, sorry, I just passed it. Like this. That's standard form. So like x and y are on the same side, constants on the other side. X and y on the same side, constant on the other side. So it's going to take a little bit. We're going to work on each one of these until we can get it to look like that. All right, so here we go. We're going to play the switcheroo game, right? We're going to move y over so it's positive and 7 over so that it's negative. We're going to move the y over so that it's positive and 7 so that it's negative. That is in standard form. We're just going to do the exact same thing for this other equation. Okay, we'll add 30 because we know the numbers need to go on the right-hand side. So we might as well get the numbers over to the right. And then shoot this guy over to the other side. All right, cool. So now the reason why we got them, it both into standard form is so that we can use stack and destroy, right? The addition method. So if we stack them on top of each other, let's stare at them. I mean, what do you guys think would be the easiest to get rid of? The X's or the Y's? Yeah, you're right. If we wanted to get rid of the Y's, this one's a 6y, right? So that means that we would need this one to be a negative 6y. So what do we need to multiply by to make that happen? Yeah.
-6.
Very good. Yep. All right, so let's see here. So we're going to get -18, -6, and 42. We're not going to mess with this guy. He's already ready to go. All right, so if we add downward, we get -22, I think. Those are gone. And we get 44. Ooh, that's a good sign. Because 22 goes into 44 exactly 2 times. Cool, cool, cool. All right, so now we're going to take that -2. And again, you don't want to go back to the beginning because those were kind of gnarly. Remember right here, we worked to get them down to looking a little bit more simple than they did up at the top. So you're looking at those and you're asking yourself, which one of those do I want to plug it into? Do you guys have a preference, the first one or the second one? Yep, that's the one I was thinking too, because y is already by itself, right? And y is what we're looking for. So we're going to take them back right here. So 3x, which is -2, plus y equals -7. There it is. That doesn't matter actually which one you plug them into. Yeah, you can plug them into either one. You'll get the same answer, you guys. So don't stress too much about it. All right, so -2, -1 is where these lines cross. Again, that means that they must be consistent and independent. Consistent, since we got an answer. And independent, because they're 2 crossing lines, not one line on top of the other. All right. All right, which method should we use? Addition or substitution?
Substitute?
Yeah, substitute. I mean, they already solved for y.
Yep, let's do it. So we'll just take this guy. Oops, get it on the marker. So we'll take this guy and we'll plug him in right there. All right, well, so this was kind of weird, huh? And what do you think that means, you guys? So 30 does equal 30.
Is that going to be like a dependent line?
Yep. So in this case, we'll have infinitely many solutions. Infinitely many solutions, yeah. And you even on top of that, so infinitely many means it has to be a line on top of a line. I don't know exactly what they look like, you guys, but let's say this is one of them. Then the other one would have to be like right on top of it. And so that is going to be our case where it's dependent. And is it consistent or inconsistent? Yep, it's consistent. We got a solution. Heck, we got a ton of solutions, right? Not only did we get one, we got a bunch more. Yeah. So the answer will be infinitely many. This is just if they ask you to label it. So I'm going to box this as the answer. All right. Oh, oops, I keep hitting that instead of the next arrow. There we go. All right. So, we want to get rid of these fractions, you guys. Because who wants to work with those? I mean, nobody. So what would we have to multiply by to get rid of the fractions on that top equation? Yeah. So everybody's going to get a 3 in the numerator. And so we're going to have 3x. And then 3's cancel here. So it'll just be a 5y. And then the 3's cancel here. So it'll just be a 1. Cool. All right, what about on the second one? What would we multiply by? 2's? Nice, you guys. 2, 2, and 2. So 2's cancel here for a 3x. 2's cancel here for a 5y. Equals 4. All right. Okay. Well, I mean, if we wanted to get rid of something, we could just like multiply by a negative to this, and that'll make them have opposite signs. So you'd have 3x plus 5y equals 1, and all these guys would be sign change, right? So
Now, how could both of those be correct?
So what is that going to get us when we add down?
Yeah.
0 equals negative 3? Okay. Good. Well, that's not true, huh? That's a false statement. So what do you think the answer for that's going to be? Yeah. It's kind of like earlier in the class, whenever we got these cases, we'd say like no solution or whatever. So it's going to have no solution. So you're right, it's inconsistent. And inconsistent would be parallel lines. So it's independent. It's not one line on top of the other line. As far as the solution, though, this is the solution, that there isn't one. So parallel lines. Good. They gave us each one of the weird ones, right? So let's document those. Weird case number 1, 30 equals 30. Okay, that's infinitely many. And then weird case number 2 is if you get something that's not true, right? Like this 0 equals negative 3. Okay. I think I've answered Melanie's question that I've been thinking about while we've been doing stuff. Visually, when you add two equations together, I think you're taking the average of them. So like, let's say I took this line and I added them together. It should be like halfway down the middle, I think. And then same thing here, this line plus this line, you should be exactly halfway, I want to say. Let me just quickly type it in to make sure my suspicion is true here. Negative 3x plus 5y equals 4 plus negative 7/4. Man, you're making me work hard here. 16 over 4, 16 minus 7 is 9. 9/4. Yeah, it looks like that is true. That this line is exactly halfway in between. You know, this one up here and this one up here. And this line is exactly halfway in between this one and this one. At this point, if I said, oh, it's halfway in between, well, that point's on both lines, which means it'll just go through that point again. So Melanie, yes to your answer from a long time, to your question from a long time ago. So visually, when you have two lines, let me make sure you guys understand, because I wasn't able to write on it. I didn't have my writing tool. What I mean by is this angle and this angle are equal. And this angle and this angle are equal. This line is smack dab in the middle, smack dab in the middle. Well, if they go through the same point, the middle of the same point is the same point. So it should go through it every time. All right. So that's a good way to check. Back to Melanie's question. All right. Okay. Word problem time. You guys didn't get enough of them, right? With 4, 6. We need some more. That wasn't enough. Okay. So here we go. These aren't too bad. This first one's kind of gnarly, but the next one's like not bad at all. All right. David borrowed a total of $10,000 to pay for his final year of graduate school. He borrowed part of the money through his school with a Perkins loan that charged 5% simple interest per year. The remainder of the money from his aunt at a rate of 1.4% simple interest per year. At the end of the year, he paid $428 in interest. How much did he borrow from each source? Okay. So I'm going to go ahead and say, get some variables picked. And I'm going to pick, P to be the amount borrowed from the Perkins loan. And then I'm going to pick A, I guess, to be the amount borrowed from his aunt. All right. Okay. So does anybody see an equation? Just any equation that we could set up? From the given.
Well, can we start with the 10,428?
We could start with the 10,000. I probably would start with that.
Well, the 10,428 is what he paid after all was done. So I thought maybe that would be one side of the equation.
If it had said, if these variables over here weren't amount borrowed, but they were like amount paid, then you would be right. Since they're amount borrowed, I don't even have to consider the 428 because all I borrowed was 10,000. So yeah, I guess if we changed what we labeled our variables, yeah. So yeah, Will has an equation and it's right. If I do P plus A, so the amount borrowed from the Perkins plus the amount borrowed from the aunt has to add up to 10,000. I don't know how it's divvied up. Maybe he borrowed 5,000 and 5,000, but nothing says he borrowed equal amounts. Maybe this one was like 8,000 and this one was 2,000, who knows? We don't know how it was divvied out. We just know it adds up to 10,000. Okay, so that's going to be one of our equations. The next one is going to be pretty tough, but hopefully I do an okay job explaining it. Here's the next one. All right, so we're going to need a formula that I would just give to you on an exam, if because it's not used very often, so I don't stress it. But here is the formula for simple interest. You can see we probably need this because it mentions simple interest in the problem, right? Right here and right here. So that's the formula for simple interest, you guys. All right. Now, Ahmed brought up the 428, right? That's the total interest we paid. So I don't have any equations yet, but I do have some like words. I know that the interest paid to the Perkins plus, I'll just write that plus in a second, plus the interest paid to his aunt better equal, right? Better equal. How much? Yeah. And again, I don't know how much interest each one individually earned, but I know that. Now, so we have a formula for interest, right? PRT. So this is going to be PRT, and this is going to be PRT. You just have to figure out what the P, the R's, and the T's are for each one. So the principal, the original amount borrowed for the Perkins, well, that's just P. We don't know exactly what it is, but we've let it be the variable P. What is the rate, you guys, for the Perkins? Yeah, 0.05, you even moved the decimal. Look how good you guys are. And then as far as time, how long are we doing this for? Yeah, at the end of the year. So just 1 year, you guys. Now over here for the principal, the original amount borrowed wasn't P. This is for his aunt, so this is A. Then what's the rate for his aunt? Yeah, the 1.4%, so 0.014, good. And that was also for a year. So we know that multiplying by 1 doesn't do anything. So we're just going to put 0.05p plus 0.014a equals 428. Okay. All right. All right, so what do you guys want to do? Do you want to move the decimals in this and then do stack and destroy? Or do you want to isolate one of the variables over here and plug it in?
I like plugging in.
You're like, oh, we're at a 50-50. Can I get one more vote? Okay, got a vote, thanks. All right, so it'd be really easy to isolate a variable on this equation. It's not like this equation's super hard. So let's say we get the P by itself. So we move the A over and it'll become negative. Then what we can do is we can take this and we can plug it in right here for the P. So we've got 0.05. Oops, I write it down wrong. Okay, so calculator time, 0.05 times 10,000. I got 500 for that. And then that's going to be negative 0.05. A lot of dots all over my screen. That are like, what the heck? Huh. Try to make sure I don't have as many dots, you guys. Sorry about that. Okay, so we'll combine like terms. So 500 and whatever the heck that is. So negative 0.05 plus 0.014. I'm getting negative 0.026. Take away 500. what is that, 72, I think? I'm gonna roll with it. All right, and then divide this out. And calculator time again, 72 divided by, oh, so the 72 should be negative, you guys. I dropped a negative on that. I was about to get, and he borrowed negative, whatever dollars. Let's not, doesn't make sense. He borrowed negative 2,000 from his aunt, right? Okay. So A is 2,000. That's how much money he borrowed from his aunt, right? You don't have to think hard. How much did he borrow from the Perkins then? If he borrowed 10,000 total.
8,000.
Yeah, had to be 8,000 from the Perkins. Now, of course, you could do what we usually do, which is plug it in if you wanted to find it. Let's say you weren't at one with the word problem. You didn't have it completely down solid. Then go back and plug it in. Cool. It adds up to 10,000. It seems reasonable. I'm going to go with it. Okay, last word problem. A plane flies from Atlanta to Los Angeles against the wind. Okay, so from ATL to LAX against the wind. All right. Oops. All right. The return trip with the wind. So from LAX to ATL with the wind. Okay. All right. So these are our two trips. All right. Now what we're going to do for these, this is kind of like the rowing the boat problem, you guys, from earlier in class. Like almost exactly like it. You're going to totally feel that rowing, against stream and with the stream. Very much like that. So we're going to use good old dirt. Distance is rate times time. Now it says, let's see here. What is the distance, you guys? What is the distance? Yeah, and it's going to be 3,200 for both because, whether I'm going from ATL to LAX or from LAX to ATL, it's the same, right? Return trips are always the same. Now, the rate is actually going to be comprised of two different things. The rate that the plane is, how fast the plane's engine is making the plane fly, but that's not how fast the plane's going to fly. If it's going against the wind, like maybe I'm flying, 200 miles per hour. But I'm going against the wind, it's going to slow me down. So I'm going to take away the wind. Over here, P plus W. The wind is going to make you go faster than the engine is actually taking you. So that's going to be the rate, you guys. All that's the rate. All right, now how long did it take from Atlanta to LA? Yeah, it took 5, right? That's the T. And how long from LA to Atlanta? 4? Okay. All right. Now, normally we distribute, but I don't know if you guys remember from earlier, we're not going to. We're going to divide them out. So 3,200 divided by 5. My calculator says 640. And this one I can do in my head because it goes into 32 perfectly. So this one's 800. Now, we're going to stack them right on top of each other because look how nice this is. If we definitely doing stack and destroy on this one, you guys, because look at that. How pretty is that? Right? I love these problems because of the fact that they'll always cancel. So you always have plus the win, minus the win. All right, so 0, 4, 14. P plus P is 2P. Divide the 2 out, divide the 2 out. 720. And at first I was like, planes don't fly 720 miles per hour, I don't think. That seemed fast, but I forgot we're dealing with, kilometers? So the plane speed is 720 kilometers per hour, right? And then you could take that 720 wherever, you know, you could take that 720 here, or you can take that 720 here. I like that one better because the W is positive. So when you plug the 720 in, you only have one step. Take away 720, and now you have that the wind was 80 kilometers per hour. There we go. And there we go.